have is this. We basically said that there can be 4 generating function. Okay, how it is derived and all, I'm not going to go to that now. But the first generating function, we basically say that it will have 2 parameters, q, small q, and capital Q. Time is there, constant everywhere. The second generating function, we have got the parameters small q and capital P, and the third would be nothing but small p and capital Q, and the fourth one is small p and capital P. So these are the 4 generating functions that we should have. Okay, and based on this, we can actually write down different forms. And if you remember, the first form that we actually found out was for the first generating function. So the form that you should remember is this. You should remember this. Okay, this is important. Okay, and out of these 3 equations, these 2 are even more important. This is very important, and this is also very important. So these 2 forms are very important, and you have to also concentrate on the minus sign. So if I'm asking you a question and you are writing down the generating function and you don't put a minus sign, you usually cannot score. Okay, so that's important because that is a part of the derivation. I also told you that you should try to find out the form of the rest of the generating function of your own. So in exam, I might ask that. Okay, so please remember the steps so that you can actually easily find it out. Okay, so this equation 11 and 12, I told you, is basically called the transformation equation. And this particular equation, which is this relation between k and h, k is the new system. Okay, this is the new one, and h is the old. This is the old one. So we have a connection between the old and the new coordinate system. So basically, this is the transformation that we are usually doing. Okay, so if we just look into this second term f2, and if we do a similar calculation as done for the first one, okay, you are going to get 2 more generating functions. That is this. So pj is del f2 del qj, and capital Qj is del f2 del pj. So you have to again remember this. Okay, and then the old transformation equation. But I think more important would be these 2, as I told. This is for the second generating function. If you go for the third generating function, do a similar calculation. See, this is the one that we're getting. Okay, so we do have a minus sign here, a minus sign here. Both the cases there is a minus sign. Okay, and the fourth form is this. This one is a minus, this one is a plus. Okay, so this is the fourth form. So your task will be actually to derive the second, third, and fourth form. Okay, the first form I have derived. The second, third, and fourth you should be able to derive. Okay, but then before that, how does the function or the form exactly looks like? You look into this. Okay, let's just have a very small comparison. I think that will be very easy for all of us to remember it better. So the first generating function is basically nothing but a function of small q, capital Q, and t. Okay, and if you look into the function here, if you look into the final form of the function, okay, see f is nothing but small q, capital Q, and t. So if it's a small q, capital Q, you will have a small qj here, you will have a capital Qj here. Okay, and then the momentum corresponding to qj would be pj, so this will be small pj, and the momentum corresponding to capital Qj would be capital pj, so this will be capital pj. Okay, so this is mostly the form that usually takes. Okay, and you know the minus and the plus is something which you should remember. Other than that, it follows a pattern. It's a function of small q, capital Q, and capital T. So on this right hand side, you can straight away write it down. Del f1, del, check the first function q1, so I'll put qj, and second would be minus is there. You have to remember that. Del f1, del the second function capital Q, just put it there, and then write down the corresponding momentum on this side. Write down the corresponding momentum on this side. If it's small, it's small. It's capital, this is capital. Okay, so this is the way to remember it. I think this should not be very difficult. If you look into the second part also, you see this is Q, so I have put a Q here, and this is capital P, so we have put a capital P here. The corresponding momentum would be small pj, the corresponding momentum would be capital Qj. This is how I used to remember, and I think this is the only way to remember it in a better way. Okay, so the first one, you see there are 4 terms, right? This is the first function, So if you consider the first function, okay, the first one is plus, the second one is minus, right? Let's consider the second generating function. If you consider the second generating function, you see both are plus here, right? So this is plus, this is plus. I think this is a good way to remember. And let's look into the third generating function now. So if you look into the third generating function, let's check this out. So see, both are minus here, and you see this is a function of small p. So remember this, So this is small p corresponding. So this is momentum. So it will be the corresponding generalized coordinate. Here capital Q. So this is nothing but generalized coordinate. So the corresponding would be generalized momentum. Both are minus here, right? So we will put this for the third one. This will be minus. This will be minus, right? And then finally the fourth one. So if you check the fourth one, okay, you would see that the first one is minus, the second one is plus. So this is also has got a sequence here. See, plus minus, plus plus, minus minus, minus plus. So that way also you can remember. Okay. So what I would suggest is first you remember how in which order you are taking the generating function. So you see here, momentum. I'll put momentum. I'll put the corresponding generalized coordinate here. This is momentum capital Pj. This is capital Pj. I'll put the corresponding generalized coordinate capital Qj. And this way you can remember all the four forms of generating function. And once I know what is the form of the generating function, let's try it out and do some sums. Okay. So I will just go back to this slide. Okay. And then I will give you something very simple here. Okay. Just to understand this, I think this is a simple example that we have taken. Now, this is a very important topic for your entrance exam. Okay. They usually give you this question, canonical transformation and the Poisson's bracket. So Poisson bracket is the second part of this unit. The first part is the canonical transformation. So let's just look into the canonical transformation part now. And let's say now till now I did not say that I have been given any function, right? I have just said that I have a function and the generating functions are f1, f2, f3, f4. So a generating function is given. Just a second. So what happens is if the generating function is given, there is a interesting part here that you have to know what is the form of that function. Okay, and straight away you can say whether it is the first generating function, the second generating function, or the third generating function. So look into the function now. This is small q capital B. Okay, then let's just go back and let's just look into the functions here. See, this was actually this is the third form, I guess. Yeah, this is the second form. The second form is q, p, and t. So it is independent of time, so I don't have to worry about time here. Okay, I think even better would be the first part of that equation that we have done. I think we can go back there and keep that handy. See here, this is the first form, second form, third form, fourth form. You cannot interchange q and p here. Okay, you have to remember this exact form. You can easily write down what is the generating function. Just practice it once or twice. You will remember all the forms. Okay, so you see, if you look into this particular question, it has got q and p, small q, capital P. So let's look. This is small q, capital P. So this is the second form. In the second form, both are plus. Okay, so in the second form, what we can write down is small q. So it is small q, and we write down the corresponding generalized momentum. And this is capital P, so this is capital P and the corresponding generalized momentum. And then this is the function f2 and this is the function f2. Why? Because it's a second generating function. But now the interesting part is I already know what is f2. This is my f2, right? So I can just replace it. So I'll just replace this value here. Okay. And then when I do this differentiation, this is with respect to qj. So this is qj. So that's just one. We're taking the total here. Okay. Summation. Everything is totaled out. So I just got pj here. So just put pj. And then capital qj would be nothing but small qj. So if you check this function, you see that this is basically forming a mirror image. Pj, small pj will become capital pj, capital qj will become small qj. So this is basically forming a mirror image. Okay, this has got something specific here. So it basically, what it does is it generates identity transformation. It's basically called an identity transformation. So this is just an example to understand. Okay, now since this is independent of time, it does not depend on time here. So k is equal to h plus del f2 del t. That was the conversion from the new format to the old format, or the old format to the new format. Okay, you know that f2 does not depend on time, so this part will become more or less zero, right? So this part will become zero. So if this becomes zero, you know this k is equal to h. So whatever is the form of Hamiltonian in the old coordinate system, the same will be the form in the new coordinate system. Okay, so k is equal to h. That's the meaning. Okay, so if you just look into this particular example, if f is equal to minus of qjpj, if I just take a minus sign, you will see that this will become minus of this will become minus of this, but k and h will remain the same. This is something which is an example of space inversion. A positive of this will give a negative of the corresponding coordinate in another system. Okay, and that is basically called something which is called as space inversion. Okay? So if we do these canonical transformations, okay, and if you know what is the form of the function, you can actually predict a lot of different informations. Okay, you can actually grab a lot of information about the system or about the function. Okay, and that is important. So let's say we have got an example. So now I'm going to a typical example. Okay, I think last time I've given this question for 7 marks. And if I remember, this has been also a type of question which has been asked in an entrance exam, in net exam, if I'm not wrong. Okay, so last time this was a question for 7 marks. So if you look into the question, let's just read the question first, try to understand what is being asked, and then probably we'll try to answer this. Okay, so uh, once we do a number of examples in this particular unit, okay, I'm also going to give you some tasks. Once we finish that, and then we are going to go for Poisson's bracket. So you see, one theory about canonical transformation, and then we're doing problems. Similarly, we'll do Poisson's bracket theory, and then we will do Poisson bracket problems. Okay, so this chapter is going to be more or less very straightforward in nature. So we are given two functions. One is in terms of capital Q, okay, and it can be written as root of Q square plus P square. Okay, this is just the form that has been given. Okay, now treat everything mathematically. Okay, forget about the physical analysis right now. Okay, and then there is a function which has been given, which is nothing but small q, small p, small q, small p, small q, small p. So if you look into the generating function, there is no function where it is small q, small p. Everything is having at least one capital function, one capital Q or one capital P. Okay, so that means we have to basically change this. Okay, in order to find out this small q into capital Q. So the question is, find out the form of PQP. That means you have to write down this capital P. Okay, so which we are going to see how to find out. Okay, in terms of small q and small p, and you have to write down the function, okay, in terms of small q and capital Q, and small q and capital Q. Okay, so what happens here is that we basically consider this function in terms of whatever has been given. So here it has been given in terms of small q and capital Q. I need to eliminate p. I need to eliminate this p here. So idea is very simple. It is just a simple maths problem. Okay, to eliminate p. Where from you eliminate p? You can eliminate the p for using the first function that has been given. So you can just write down p in terms of small q and capital Q. Replace it here, get your answer, and that's the best way to do it. Okay, so let's see the question now. So how can we answer it now? So FQP needs to be written in the form of F small q capital P. So let's just take this q is equal to root over of q square plus p square. Okay, and then we can write down p square on one side, and this would be capital Q square minus small q square. Okay, and then we can write down what is p, root over of capital Q square minus q square. So you can just replace it in this function, whatever has been given. In place of p square, we can write down this. Okay, so we'll take this tan inverse of q by p. So q by p is root over of q square minus q square, so that's replaced. Again, there is a p here, this is also replaced, right? So in this particular term, what you see is this, and this will get cancelled, right? And then what you have finally is this equation, half q square sine inverse of small q by capital Q, half of q root over of q square minus q square. Okay, so the obvious question is, how do I get to sine from 10? And also another question is, can I keep it in this form? So if I'm asking you a straightforward question and you are not changing it to sine, or I specifically don't ask you to write it in terms of sine, I think that's fine. Okay, you can keep it in terms of 10. But then, you know, when you give those entrance exams, they have got those multiple choice question. In the multiple choice question, they will straight away write down this form, might be, and they don't write down this form. Then you should know that this form is also correct. So how do I get it right? So you know, tan inverse is q divided by root over of q square minus q square is equal to, let's say, theta or x. Okay, so I'm just going to show you this derivation, how we arrive from tan to sine. Okay, try to make it as detailed as possible. So tan theta can be written as this way, because you know it's written that tan inverse is this. So that means tan theta should be this, right? Inverse function. So what we can do now is we can just write it down as cos sine theta by cos theta is equal to this. Okay, and you know that tan theta is equal to nothing but the opposite side by the adjacent side, right? Popularly called as perpendicular by base, but I think sometimes it's not correct to say that. It's always opposite side by the adjacent side, right? So opposite side by adjacent side is given to be the form of this by this, right? But for sine theta, you know, you need the opposite side divided by hypotenuse. So you already have the opposite side by the adjacent side. So the hypotenuse can be easily found out using Pythagoras theorem. Because you use Pythagoras theorem and you take the hypotenuse. So sin theta is equal to nothing but opposites divided by hypotenuse. So it is q divided by capital Q. So theta can be written as sin inverse of q by capital Q. So tan inverse q by q root over q square minus q square is equivalent to sin inverse of small q by capital Q. So we can just replace it here. And I have shown the steps. You really don't need to show the steps. Okay, I think this is very basic. Okay, and then we should all know this. Okay, more or less simple. And this second form remains the same. So now you see, you have to write down this function in terms of small q and capital Q. So it is written in terms of capital Q, small q, capital Q, small q, capital Q, capital small q. There is no other external term. If any of the term remains, if you get a more complicated question, then you have to still keep on doing it so that you finally get the form that is asked in the question. The next part of the question is find out P in terms of small q and capital P. Let's do it. Now what we are going to do is we are going to use the generating function. See, we have written it in terms of small q and capital Q now. So that means if we write it down in terms of small q and capital Q, that is the first generating function. Okay, and the first generating function is, if you remember, it is minus and plus. Okay, and then you can take del f1 del small q and del f1 del capital Q, write down the corresponding momentum on the other side. Okay, so I can simply write it down this. So first term is minus del f del q. Okay, and then you just do the integration. So if you do the integration, you should be able to get the answer. Okay, so I'm not going to explain this much. It should be easy. Minus of del q is equal to half of q square sine inverse of small q by capital Q plus half of this. So we're using the new form of the function that we have taken. Okay, so don't get confused in exam that first question is capital P Q P, then should I do the first one? That no, you first need to know the generating function, and then only it will be more easy for you, right? Let's just do the differentiation part. I think this is two forms are given. This is also having capital Q, this is also having capital Q. So we'll use the product rule. So if you use the product rule for the first one, this will be ddx of x to the power n. Okay, is nx to the power n minus 1. So just get 2q here. So 2 gets cancelled. It's just q, and this is sine inverse of small q by capital Q, right? Plus half of q square. This term will remain here, same. And then you differentiate and take the inverse function. Okay. So sine inverse of small q by capital Q, okay, is nothing but if you do it minus of I think x by y, okay, or some form is given del y of minus of x by y, sine inverse of x by y. You will have this as the standard integral value. So please check this, okay. And then you go for the second one. In the second one, we have just got this part, right? So what you do is you usually take this entire function, you do the replacements and do it accordingly. And I'm not going to explain this. I think this is very basic differentiation. Just take this, take this, take this, right? So if you just differentiate this, okay, I think this is also simple, right? Half nx to the power n minus 1, q is there, you can just take it out, that's constant. Half is also constant, take it out, just differentiate this part, right? So it will be nx to the power n minus 1, so this is your n and entire part, half is n, so it is x is this to the power n minus 1, and then you differentiate this separately. So if you differentiate this part is 0, and this is ddq of q square, so that is 2q. So just take this 2 to cancel, and then you can just do your sum, and then you see that this term and this term will more or less become same, so they will cancel out. So what you finally have is a very simple equation of minus capital Q sine inverse of small q divided by capital Q. Okay, so we can actually do a lot of sum here, okay, and if you really want to understand this, I think I have explained this also, but then I think it's okay. If I'm putting the video, you can always pause it and have a look, okay. Why does sine inverse of small q by capital Q turn out to be the result that we finally found out? So you can do some replacements here. You can write down sine y is equal to small q by capital Q. So sine y can be written as small q into capital Q inverse, and then we can differentiate it, okay, with respect to capital Q. So we differentiate it, this side you get cos y dy q minus q divided by q to the power minus 2, okay, and then I will just put this on the entire screen, okay, and then you can check it. I think this is very simple steps, okay, no need to explain much. So finally you should get this result. So but in exam, even if you don't show it, you remember the final result, it's fine, okay. Sometimes you do need to remember because you might not have that much of time. Anyway, so see this. We needed to find out in terms of small q and small p. So we have already found out an equation in terms of small q and capital Q. We are not even using the second relation for F1, okay, generating function F1. So P of small q capital Q is minus q sine inverse of small q by capital Q. We need this. So that means we have to replace this. We have to replace this. And we already know what is this, root over q square plus p square. So just replace it. So this will be minus of root over q square plus p square sine inverse of q divided by root over q square plus p square. And you get the final equation, right? Similarly, like the last one, we can also write it down in terms of 10. You can keep it here. And if it asks specifically write it in terms of 10, you can just get back to this 10, okay? So this is important, okay? And these kind of sums are quite popular. And please remember that this is, if you know the form, the generating function that we're talking about, that is what comes from the theory. But other than that, it is all about differentiation, putting the right variable, doing the correct example, okay, solving it correctly. That's more important. Okay, so this is where we stop for today. This is an important example, so I've just explained this example. In the next example, in the next next class, we are going to talk about condition for transformation to be canonical in nature. Okay.